The hands-on 03 machines. Meanwhile, we will talk about stuff. So 3 kinds of NAT. What were they when we actually go to configure them? Static. Not dynamic. But there's one that starts with a D. And then there's another one that starts with an S. Not stateful. Not stateless. They have to do with directions, kinda. Down, no.
Are you sure?
But if we have static, I mean, did someone already say dynamic?
Yes.
Okay.
So at home, you do NAT from your network out to the internet. So when you're doing this kind of NAT, you're worried about where the traffic comes from. So when we talk about where the traffic's come from, we want source. So destination is our other kind. So in static NAT, what is that doing? So we'll have, with any of the NATs, we're going to have like a internal IP. And how many external IPs are attached to static NAT? When we have one address? 1. So with static NAT, for every internal IP we have like this, we're going to have a thing like this going on. They don't necessarily have to be in order. Like we could do like so. We could actually do static NAT by like that too. So static NAT, though, the key thing is we are tying one IP address, one inside to one outside. That's what static NAT has going on. In static NAT, we're not worried about ports or really anything like that. I mean, there's goofy ways we can do ports, but we're not going to worry about ports. Generally speaking, static NAT, one IP address to one IP address, and nothing in between. Destination NAT, what is that concerned with? Oh, and the other thing with static NAT is it's direction agnostic. Either direction, doesn't matter. We're find and replacing. Either way. Destination is find and replacing, generally speaking, in what direction? Or when we would say, when we look at the traffic from your house, can we predict the destination of all of your traffic? No. What is our area of doing firewalling, networking, where we do know the destination that will exist inside of the packet? When there's traffic coming to us from the outside, like if we're running a server. So destination NAT is usually used when you're running a server. You're going to have one IP address going to, and then the key thing here is you're generally going to use ports. You don't necessarily have to, but generally speaking, you're going to be using ports. And it's one way. It doesn't go the other way. So if 192.168.1.100 wants to go out to the internet, it won't get translated to this IP address. If it were static NAT, it would get translated back to its origin. But in this case, it's not, because it's destination NAT. Do you have to use the same ports? No. Because we could totally, let's say we have 2 web servers running on port 80. Does this work? No. Why does this not work as is? Yeah, because port 80 on this IP address is already busy between the 2. But we could do something like that. That's pretty common to do. Then does anyone, or does this web server, is it aware that there's any NAT stuff like that going on? No, because the packets it receives are already translated, switched around. Source NAT, what's that going to do for us then?
It's gonna map it back to the proper machine on your network.
Yeah. So when we take source, we'll have something like 1.100. Who does your computer hand its packet to? Whoever your gateway interface is, and that's kind of assumed in the other ones too, which is going to convert it to what? Whatever your public address is, and then send it out to this. Now in source NAT, we actually are starting to concern ourselves, we're reviewing here, with ephemeral ports. So beating this to death. Here, what's the ephemeral port used for?
The port that it will connect back to, or it will send it back to.
So it's going to be the port that the traffic comes back to, and that's going to tell your computer what?
What it is expecting.
Well, yeah, that's what we're expect, but it's already expecting that. But when it receives traffic back on this particular port or this socket, what does it know to do with the data it gets?
Service or application.
Yeah, it knows to hand it back to Firefox, right? Hand it back to Chrome, hand it to whatever browser you're using. How about here? When 24.220.181.100 receives a packet back on an ephemeral port or receives a reply on an ephemeral port, why is your router using the ephemeral port? Yeah, because it needs to know what internal IP address to send it back to, right? So why don't these two ephemeral ports match? They don't have to match. And why rarely are they ever going to match, actually? This one is totally coming up with something at random. What if we had something like this going on? Could you now, let's say that it did, because you can actually configure a router to match them. So is this going to work now? If we have two different IP addresses? No. But when we go back to the client side, is it possible for two clients to pick the same ephemeral port? Yeah, it totally is, because they're just pulling it out of thin air. So is it possible they could both pull the same port out of thin air? Yeah, they could. So that is why over here, it always makes up something weird and totally random. What other limitation can we run into a source NAT when we start to scale out networks? What area do we run out of space in? Yeah, it's ephemeral port. How many ephemeral ports can we actually end up with? Yeah, there's 60, it's 65535, I think. So if that would be all of the ports.
Yeah.
So you're probably not going to use all of those as ephemeral ports. You're probably only going to use, I think, 1024 through 65535, I think. So actually, that I don't even think is right.
I think they bumped that number up.
Yeah, that number is, it's going to be, it's not that. Anyway, so if you have 20,000 devices on your network and they all make 20 connections out to the internet, is it logical for a device to make 20 connections out to the internet? Totally is. So if our router sitting on this IP runs out of ephemeral ports, what's going to happen? Yeah, not much is the answer, right? That next session comes in, the router's out of ephemeral ports, so you can't do anything. So this is where on source NAT, we can actually end up with, like when we go to configure this rule, we could end up configuring something like, well, it probably wouldn't be 192.168 because that'd be a pretty small network. But let's go 10. Let's say you just have a really huge internal network, which would be rare. This isn't going to work because how many IP addresses are here? I mean, this will work unless you fill up that. If you fill up this subnet, how many is there?
A whole lot more
Yeah, there's like this subnet, assuming you actually have that subnet configured at home because you have that many devices, it's like 2 million or something like that. I don't even know the number. It's 2 million something. So this isn't going to work because how many ephemeral ports do we have? 65,000, assuming we were able to use them all. So that's not going to go at all. Actually, the ideal way for us to do this would be... There we go. Is this even going to work? Because how many IP addresses are here in slant 16? 65,535. So this would give us enough for each computer to have one session. Not probably going to go. So what we would end up with doing is somewhere over here we'd say like .100 through 105, or realistically, not knowing where the subnet would fall into place, but we'll pretend it's at 100 and we'd go like /28 or something like that to give this a small pool of IP addresses to use. At home, what would this look like if you went and configured a slant 16? How many IP addresses do you have sitting on this other end? Yeah, you have one. So it looks like that when we actually build out your source NAT rule. And when I say we build out your source NAT rule, meaning your router just does it and you never see this ever. So what we're going to do is walk through moving a network from being, well, we're not really going to move it. We're just going to wipe this out and start over. Moving a network from being not natted, because right now everyone had public IP addresses. So we're going to take it from being not natted to being a natted network. So I apparently broke my router. But the command we will run when you get into your SRX, maybe, if I can get into mine. Oh, there, I was just sitting there beating on the screen. Will be request system 0 eyes. So request system 0 eyes, guess what this does? Yeah, it zeroes out the firewall's configuration altogether. So if you were doing this for the homework that was due this morning, it's totally going to blow your stuff away, FYI. But that's, yeah. So moving on. Did you have a question? Or was it about that? No? Okay.
I got a command not found.
Are you inside of the edit mode?
Oh.
So do you have a... Oh, yeah, make sure to hit CLI, too. If you're, like, completely logged out.
Okay.
If you're all the way back here. I cheated because I was logged in from the class this morning. Yeah, so you gotta go CLI to get in here. Then you can do request system 0 eyes. And it's gonna be like, are you super duper sure? And you're gonna be like, yeah, I'm ready. And then I actually like that it issues a syslog warning. It's like the last log you're ever going to get from that firewall while it's like, yep, we're blown away. Goodbye. So QUESD system request system 0 eyes. There we go. So right now inside of this network we had a WAN interface, we had a LAN interface, and a DMZ. So our WAN interface, we're still going to configure that with a public IP address. 24. What should we do on LAN? Sure. That's a healthy LAN IP address. So I go back to, like, if I were to gamble, I would bet almost all of your subnets at home are probably 192.168.1 dot something. What should we do for our DMZ? We could do something other, or a different 192.
If we're following the pattern that we've been doing.
Let's go. How's that sound? Not enough?
Get more.
There, how's that? I suppose technically we could actually do 255. Is that different enough?
I don't care.
No.
Same with here, I guess we could actually do 0 as well, but that would be weird. Everyone does 1. Not that 0 wouldn't work, but everyone just does 1. So, my zeroizing, mounting the file system. So she'll be back here shortly. When we get back up, what is our, let's see, this is going to be on this interface. This will be on that interface, I'm pretty sure. There we go. So those are our interfaces. All right. Are we ready? All right. Get into our editing mode. What is our command? Set interfaces GE000 unit 0 family. What's our protocol family we're configuring this interface to be on? iNet. And then our choices of things to set on here. There are actually a few things we can set, but we just want to set address. So set interfaces GE000 unit 0 family iNet address 192.168.1.1 slant 24. And then if you want, you can like, if you were SSH'd into this, this would go a little bit quicker, but you could like arrow over, hit up, arrow over, change it to a 1. Or you could just type these things out. That's normally what I do anyways, just retype them. But our WAN was 102/24 and get our addresses configured. Here, I'll zoom this over here, and so you guys can see the IP addresses, and I'll hang out. And honestly, you don't have to use these IPs. I just what I'm using. So inevitably, when I start typing one of them in wrong, if you're using the same ones as me, then you can catch me. So do that. What's our last thing we need to do? We can commit. And what's it mad about?
Password.
Need to set a password. Set system root authentication plain text password.
Do you do that in top?
Yep. If, well, I never actually went into the interfaces like subconfig, which is why I always had to do set interfaces instead of just set gig eth 000. So we'll set that password. The other one, like when it comes to, if you were actually to blindfold me and sit me down and be like, what's the command to set the root password, I would be like, it's set system root, and then I hit tab, and then I know my next thing is something plain, and hit tab, and it auto-completes it for me. So if I'm like zipping around these, I'm like, how is he typing them so fast? I'm hitting tab every time because I don't have the slightest idea what the configuration options are. So now we'll commit it. And oddly is actually taking a second. Oh, there we go. All right. Anyone stuck? Blow it up.
It's still.
Or still committing? Yeah. So while it's doing that, we're actually done from the command line in there. What are our next I mean, it is what it is. That's the command you need to enter, not the actual carriage. Just hit tab. What's the next thing we're going to need to do if we want to get to the actual web interface to configure this now? Yeah, we're going to have to go into this admin machine, and its IP address is not going to be what we need, essentially. So we're going to have to switch it around. And I don't think the SRX is running a DHCP server. However, that is a thing. Like, you notice that when we would go in to edit this, what's actually happening, since this is the SRX in band or out of band management? In band, yeah. And the way we can tell, trivia question of the day, is how actually can we tell, even just by looking at the box or looking at the VM, that it is in band management? We can look at the box even this way. How can we tell that this is in band management here? There's not an interface. There's not like an interface doubling up on the LAN. Like when we look at, let's look at an SRX 220, which is a equivalent physical version of. I like that I search SRX 220 and it links this wireless G. Oh, that actually is a something. Mm-hmm. With SRX 2. Goodness. Interesting. Cisco grabbed it. An SRX 220 is a Juniper firewall as well. So, well, we can just use this particular one. So looking at this guy, does it have out-of-band management? What is this console port used for?
For the admin machine? So the interface port?
It's not an interface. Well, I mean, it's an interface. Would you plug a cable into that and then plug it into your like Ethernet port on your computer? No, what would you plug this into? Yeah, realistically, you'd plug it into a USB to serial adapter. I mean, if your computer had a serial port, you'd plug in a serial console cable to this. The rest of these, you notice, are all just Ethernet ports of some sort. If we look at down in my office right now, it's quite loud. If we look at, yeah, look at that, it's a piano too. This is a little harder to see because it's not an official. So this is a console port on what's sitting down in my office. This one says management on it. So with this one, it's actually pre-configured with an IP address right there. Generally speaking, if you get a firewall that comes and it does not have an out-of-band management port, if it's in-band, what they're going to do out of the box is set interface 0 to be the management interface. So actually, if we had started up this SRX after zeroizing it and did nothing else, since our LAN is plugged into interface 0, it would actually spin up a DHCP server and try to get you management access to it. Then we committed configuration and stuff, and then it's like, oh, I don't need to do that anymore. They must know what they're doing. Whereas this one, none of these ports will do anything out of the box. If you plug into this one, it's not going to give you DHCP or anything like that, but it will have itself configured to be like 192.168.1.1, and then you just log into its web interface from there. So if you're ever struggling to figure out the difference between, like, is this a management or a console port? Does anyone know an easy way to check? Well, ideally they're labeled, yeah. Yeah. Generally speaking. The other thing is usually the management ports, which are going to talk Ethernet because you'll plug it into your network adapter, are going to have blinky lights on it. Whereas console ports, since serial, there's no link negotiation that goes on with RS-232, which is what serial really is. You just plug it in, and that's why you have to set, like when you open up PuTTY or TerraTerm or whatever, you have to set a baud rate and stop bits and stuff like that. You have to negotiate the link. Whereas when you plug in a cable to a Ethernet interface, the switch or the router or the whatever configures all that stuff for you, and it's just, you're just blind to it. It just does it automatically, which is pretty neat. Anywho, we're in band management. We need to come in and, since there's not a DHCP server set, we need to set an IP address on our admin machine. I'm going with an exotic 1.100 on here. Figuring that. And then my other Windows pro tip is sometimes when you configure an IP address in Windows, it just like doesn't apply it. Like it's just a fun Windows thing. It was like mad and misvalidated it or something like that. And it happens in like physical machines, virtual machines, like it just happens sometimes. And it's totally random and you totally will spend a ton of time tracking down a problem. So basically the moral of that story is every time I set an IP address in Windows, I immediately follow it with going and running ipconfig to make sure it took it. Because what will happen is these will either be zeros or it'll be a 169. So if you have someone ask you, oh, did you get an IP on your computer? And you look and you have a 169 address on your computer. Do you have an IP on your computer? I mean, like, technically you do, but is it an IP address that's going to get you anywhere? No, you have an absolutely useless IP address. So 169s are stupid. That's where I believe Microsoft was the big pusher of that, of like, we're just going to configure networks and they're just going to dream up their own IP addresses. Yeah, so no one did that. So we should be able to log into our firewall now. Here we are. Let's break it. All right. I'll hang tight. Did everyone get into your firewall interface? So first thing we need to do is go set up security zones. That's the first thing we need to do. So if we come in here, zones, we want to add a zone. We'll call it internet. Get the zone set, and we also need to add a DMZ zone, like so. I'm also, as an FYI, kind of like when you're writing code, you should just compile it every once in a while to make sure you have, minimal amounts of errors in your code. I'm also a big fan of, as I'm configuring a firewall, to try to commit the config every once in a while to make sure it's correct. Or even just validating it, even though you can't validate it from the web interface. But that way when you're done and something blows up, you don't have to discard everything you've done. So we get the configuration committed. Right now, actually let's do this. Let's go make a policy that allows our admin break it?
Yeah.
What'd you do?
I can't reach the firewall page.
Alright. So what I'm going to do now, let's look at untrust to the internet. Should have called it tubes. But right now, our admin machine can't get out to the internet, right? Safe to say. Let's make a rule to allow ping. Yes?
What was the default credentials for logging into the JunOS interface?
Whatever you set it to. Username would be root, and whatever you set when you... You didn't expect that as an answer, did you?
No, I didn't.
What is it? What is the password? Whatever you put. So
Password 1 bank sounds good.
So we're going to allow untrust, 'cause that's what the zone's called, to internet ICMP. So we're going to allow ping out, because that's the exciting thing we're going to do today is
Oh, here.
allow a ping. So we're going to go from untrusted to the internet. Do we know our internal IP address that could be going out? Assuming we're allowing the entire internal network or the entire untrust zone. We won't necessarily know specific addresses, so we can just do any. What's our destination address going to be when we're going out to the internet? Any, because we don't know, right? And then our application will be, for allowing ping, ICMP.
But there's just a ping one.
There is just a ping one. Well, it's ICMP 6. Oh, no, there is ICMP ping, yeah.
Oh, right.
So you could just allow the ICMP ping. There's other types of ICMP packets going on, but yeah.
That one annoyed me.
That's what I used for the lab.
Oh yeah, I did too. But still, this man, I'm trying to get it.
That's pretty easy.
So I'm going to commit that. So, at this stage, can our admin machine ping that internet computer? It can't. Let's try it. The internet computer, if we go over here and go ping 24.220.181.100, I'm pretty sure is its IP address. It's failing. How come? No, but I did write a routing table, or it's on the same subnet, so it will work for that reason. So, have we created a NAT rule? No, we didn't. So right now our packet from 192.168.1.100 goes to, where's the next hop it makes? Why does it go here? It's the default gateway. Subnetting love, it's like, hey, you're leaving your subnet, you need to go to your default gateway. Then, where would it go next? It goes out here. This is the internet computer right here. So when I send that ping packet out, I neglected to have Wireshark put on there. Did the internet computer get the packet? It did. It did get the packet. The problem is the internet computer is... Nope, it's not a zone problem. It's a NAT problem. So when the internet computer, a device on the internet, receives a packet from what address did it come from? 192.168.1.100. Can something on the internet get to that? No. Now that being said, the internet computer 24.220.181.100, it tried. It tried to reply back. But I have these trickily configured to actually act like they're really on the internet. So when it tried to route back, does this computer on the internet know how to get to this? Not without NAT, because, well, yeah, at this point it's like, it beats me. I have no idea where that's at. What do we want this computer on the internet to try to reply to? This is without NAT. Let's do a without NAT. Now let's do one with NAT. With NAT. Right here, we're going to kind of put that in parentheses. So this is going to get sort of changed to 102. Where did this IP address come from? This is what we want. Why did I dream up that IP? So you typed it in the lab. This 24.220 address yeah, That's our internet-facing IP address. So we want, let's look at it this way. Is this a device? A standalone device? This is a device. It's a computer, right? It's a thing. Is this a thing, a device? Is this a separate device here? No, this is all one device. This is our router right here, or our firewall. Is this a separate device? Yeah. So what we want is when this computer sends a ping packet out, it gets handed to the default gateway. The default gateway should look and be like, oh, you're going out to the internet. What do I need to do to the packet? I need to NAT it. I need to do the old find and replace. That way, we don't have this going on here. We have this going on. Can our internet computer get to this IP address? Or can it mathematically, internetly find a way back to it? Totally can. What kind of NAT is this? Source NAT. It's source NAT because we want to modify all the traffic that comes from right there. We want to modify all the traffic coming from that particular source going to the internet. So if we flip over to our firewall, we've been playing around under the security button. Now we're going to move to the NAT button. Fewer buttons underneath the NAT menu. So where are we going to start? Source. So the first thing that JunOS wants us to do for the UI here is basically like sort of kind of make a folder, I guess, is kind of what it's doing. So we'll go add up in the top corner here. And when we go to add, it's going to want to know this is usually how I name it. It wants to know we're going to apply this source NAT to traffic coming from something going to something. It is not worried about IP addresses yet. We're like a level of abstraction up where we want to go from one zone to another. Because we have stuff going from crossing from the inside zone or the untrust zone to the internet zone. And that's what we want to do the NAT with. Do we want to do NAT from like going the inside zone to the DMZ zone? Oh, that would be weird. Like you don't want to do NAT unless you have to because it's dumb. And that's the technical reason why. What's that? Oh. So our zone is going out to internet. We could also do this by individual interfaces, but that would be silly to do. So I'm going to skip this part here. We're just going to hit OK. Just get our folder made. I'm just doing that because it'll look nicer when we're doing this. So, does what I've done so far make sense? We're taking traffic from one zone going to another zone. We still haven't done any NAT though. All we've done is say like we're building the filter a little bit. So now we're narrowing it down. Is this filter going to do anything with DMZ traffic? No. If our server tries to ping out to the internet, we're not going to NAT it because that's a different zone that we haven't made a filter for. Generally speaking though, like I don't make NAT rules for my servers because I don't want them on the internet. So the next step, once we have this rule set made, we need to make a rule inside of the rule set. So we hit the add button down there. We're going to make, I suppose it's not LAN, it would be, well, no, I'm going to leave it as LAN. NAT traffic from the LAN going to the internet. So the way this is set up, this whole first part here, actually where it says match, we're still making the filter of like what traffic is this going to apply to. This isn't doing anything yet. The doing is going to happen down at action. So when we go to match, what is the source IP addresses? That's what it's asking us here. What's the source IP that we're going to see traffic coming from? 1 dot, in this case we'll do 0. Because we probably don't want to NAT just one computer, we would want to NAT the whole subnet. Now in our case there is just one. But this is, the rule we're building right now is the rule that your like home router has running in it. So for in order you to get out to the internet, it has like, okay, find all the traffic coming from 192.168.1.0/24. So that whole subnet, we're building out the filter. What's our destination? Anything on the internet. What's the IP address of the internet? 0.0.0.0/0. Yeah, I don't know if I counted my zeros right. Just some zeros anyway, right? Technically, you don't actually have to fill that one in, but you just should. So, follow what we're doing so far. We're building out the filter to see, hey, what traffic does this apply to? The last thing is, okay, you filtered it out. It's kind of like our if statement again. We're writing an if statement with the conditions. Well, now that we've had a condition that matches, what do we want to do to it? The default is don't do anything. We want to do something. So we have two choices. We can do source NAT with pool or source NAT with egress interface address. What do you suppose the difference between those two is?
Well, does it have multiple egress interface addresses?
Not necessarily multiple ingress addresses, but multiple. Your egress interface is going to have what kind of address? Public IP. So if you had multiple public IPs, that's where you do the pool. Or is that what you said?
That's what I meant, yeah.
Oh, okay. Okay. So by default, this is the choice that your home router has. It's taking whatever IP address exists on your WAN interface or your internet-facing interface. Why do we have this instead of us manually configuring a WAN IP address to go out?
Could you be spoofing your IP in that way?
Could be. Think from a different perspective. Where do you get your WAN address from? Did you configure a static one at home? No. You were given. It was given to you via what? DHCP. DHCP handed you a public IP address to run on your router. So, is it conceivable that that address might change? Totally could. Do you want to come in and rewrite your NAT rule because you got a new DHCP address? Probably not. So that's why, generally speaking, routers are going to have that particular option to use the address from the egress interface. The other option with the pool, which is what we're not going to use, but that's where we could statically set a IP address or a range of IP addresses if we had thousands of devices. But we're just going to do NAT with egress address interface, and then it's going to figure it out for us. So that's the nifty part about that. So if we go commit, now when we go out to ping, we get replies back because our router is maintaining a table and finding and replacing the address so that the computer can find a way to get back. So, questions so far on source NAT? Nothing? So, the other kind of NAT we will play with today is destination NAT. So for destination NAT, what we're going to do, make a new slide here. Destination NAT. The idea is, how many public IP addresses do we have right now on our router? 1. So we want to take 24.220.181.102, and we want to host stuff on it. Something that happens all the time, right? People want to host crap on their one public IP address. Not a big deal. So with destination NAT, we want to take packets that come from where? Yeah, the internet. With destination NAT, do we care about the source? Now, we can, but generally speaking, we don't. So we want to take traffic from tubes going to our IP address on a particular port. Then what do we want to do with it? We want to rewrite it to be like so. So now when this computer gets the packet, it is actually going to see this original source. But when we actually look at this again inside of the bubble, slash like sort of here going on, we're going to rewrite the packet to get to here. When this replies, it's going to unrewrite it so that whoever on the tube see that it came from the original place it asked from. So doing DNAT. Let's go configure DNAT, huh? Yeah? See? No one got it. But that's fine. What's that? No, it's DNAT. So we're going to go configure DNAT. Yeah, see? See?
It got funnier the second time.
Yeah, you had to warm up to it, right? And so destination NAT, add, again, we're making a rule set. So we'll go DNAT, internet. And same thing again. It's going to ask us now not where the traffic is going to, or like from to. It's just going to ask us, okay, since this is destination only focused, what's the destination going to be? And our destination is going to be like traffic hitting our internet zone, because that's what we're looking for. And I'm going to hit OK to make the rule set. You could just hit the little add button inside of there too, but this is just sort of how I roll, I guess. So we made the rule set. We're going to add stuff inside of it. So we'll go DNAT, internet, DNAT, internet, server 1. So here is where we can actually worry about the source. But generally speaking, doing destination NAT, do you care about source? No. What's our source going to be? It's going to be the internet. And what was the IP address of the internet? Zeros. Boom. So this is the next thing. What is the destination IP address actually going to be that we're worried about? It's this one, right? So when we're doing source NAT, this was set up to handle DHCP, like our internet-facing IP address could change, right? Destination NAT doesn't do that when we're configuring that. Destination NAT, we have to actually type in an IP address. Conceptually, if you think about that, why would that be the case? But if you're using DHCP, might your IP address change? Yeah. But that comes to the next question. If you're hosting servers, like real servers on a network, say you have a commercial firewall, you probably are doing something for real. Are you probably on home internet connections only getting DHCP? You probably have static IP addresses. So when you go look for like mid-continent internet and you buy it for your home, what's the difference between that and the business package other than about $30 a month? You can request static IP addresses from them. They're not necessarily happy to give them to you, but you can request them and they'll be like, well, fine, we'll give you a few. So
would it be cheaper just to request a static IP address through like a VPN provider? So when people try to contact, you can just give them the VPN address to contact the web server?
That's a good question. So when we talk about that, yeah, you could get a static IP address from a VPN provider. Then you'd have to maintain a VPN tunnel between you and the provider at all times, right?
Right.
So what you'd actually be doing then is taking web requests from an outside source, tunneling them back to your network, and then serving them through that tunnel. So what's that going to end up introducing?
Latency.
Latency, yeah. So that's why you could do that though, but you probably wouldn't. You could also like stick a NAT router somewhere where you had static IP addresses, and rather than this be really screwy, but you could actually use a router on the internet to rewrite the destination IP from one internet source to another and send it back to your home DHCP thing. But that would be silly to do, is what we'll call that. So, but it could be done.
It's like that stands for something less friendly than silly.
It does, but not something I'll say. So, we have destination NAT. We ask for a port. Let's do port 80. So destination NAT, we're going to hit 24.220.181.102 on port 80. Then the default choice is to do nothing, or we have to add like we want to send it to someone, right? So we'll go server 1 HTTP, because this is not going to just be a IP address. It's going to be an IP address port combo. Whoops, and that's 192.168.255.100/32 on port 80, because that's where we will find the web server at. Does that make sense what we're adding here? We're adding a specific IP port combo to get to. Here, I'll flip over and figure. I'll pause. Pause is shown. So we'll hit OK on that. And then add it in the pool, or find it in the list. So we're taking from any source to this IP address. Oh, we also need a slant 32 right there. Going to that particular port. Looks good. We'll hit OK. And we'll commit that. What we should find now, if we venture over to the internet, is I cheated because I had it open earlier. Close that. We need to change one other setting. Does anyone know what the other setting is? It's not a setting in the firewall.
Setting for Windows and this machine. Set the IP.
We need to set the IP in the server, yeah. We didn't do that bit yet. So right now what's probably happening is our router is sending packets out
To no one that's listening.
to no one, to no one that's listening. And it's sitting there being like, why doesn't anybody want to play with me?
Sits in the corner and gets all sad.
Yeah.
Sad.
So this would be 192.168.255.100. Like so. This. Now let's do our official test, see if it'll work.
We're gonna wait. Gives you 181. That one.
I should make sure I actually committed that. Yeah, I did. Oh no, a crisis has occurred. It's not working. So it ARPed it, so we got that going for us. Oh, I know what's wrong. So we made a rule in NAT to find and replace the IP address, right? At any point, did we actually ever tell our firewall to let the packet through?
No.
No. There's that allow thing.
Yeah. So that's where the old magic comes in again of NAT and firewalling is not the same. So what we just did was told our firewall or our router or whatever you want to call it to change the IP addresses around in the packet. So when we receive a packet in, NAT is going to do its thing first. Then it's going to hand it over to a firewalling process. So in our scenario here, when we look at policies coming from the internet zone to the DMZ zone, is there anything there? No. So what's it doing with the packet? It's probably getting there. And we can actually, if you go to monitor again and go to NAT and look at destination NAT, just to test if your NAT rule is correct, it keeps a counter of like, yes, I'm doing some destination NAT. And in our case, or at least my case anyway, my DNAT internet has had 12 translation hits. So it has switcherooed 12 packets for me. It just happens that when it handed over to the firewalling process, the firewall gave it the middle finger and just dropped it. So we need to go from internet. Well, I guess we can just hit add right here.
I just love that.
So we're going to go allow internet DMZ server 1 HTTP. And we shall permit said traffic.
We're not going to deny it.
No, we're not going to deny it this time. We're going to go crazy and allow it. So do we know the source of the traffic?
No.
No, we don't know the source. And we can actually cheat and just hit add destination address here. So we'll go server 1. What is the destination IP address going to be? Is it going to be 24.220.181.102? Or is it going to be 192.168.255?
Now I switched it, so it'll be the actual 192.
Yeah, this is the firewall rules get evaluated after NAT does. So in this case, it will be 192.168.255.100. So if we add that, it'll appear in our list. We can scooch it over. And we'll add HTTP. Now, maybe this time, this is the third time's a charm, for me getting this rule to work for us, for our NAT to work. We'll add that. Actions commit didn't show up for me because I don't have the filter set right now. Let's make sure it's there. Internet to DMZ. There we go. There's our allow rule. Now do you suppose it'll work?
I suppose.
Hope so.
My faith has been shaken.
There we go. Well, I was starting to get a little nervous too after I'd tried twice and forgotten 2 different things and went through it. As you can tell, I'm not like cheating with a list of step-by-steps up here and I'm just reading them off to you, right? I'm just kind of making this all up as I go. So, yeah, everyone gets to learn a little bit. So we can also do weird stuff, like we come into NAT and destination NAT and take this destination IP address of 80. We could make it 4321. Is that going to cause any problem with our firewall rules or anything like that? The only one that's going to be upset about that is going to be our browser. So if we come over here now, go :4321, because the natting happens before the firewalling. So by the time it hit the firewalling part, that whole 4321 is gone. It's just trying to get to port 80. So, any questions? A few people stuck and want some help, and I'll hang out for that if you missed something. Otherwise, I did record what we walked through, so that'll be uploaded, and you can check that out. Sound good?